Hello and welcome to Easy Projects. So today we will make the enclosure for the DC load, and as I said earlier, I will make it on the laser cutter. So it will be made out of sheets of acrylic. So that will be something like this. And I actually picked up a whole box of scrap acrylic plate for almost free. It just have some marks and nicks here and there. But most of these are actually not even through the protective film, so it's almost like new. But in some places there's just a little mark in the plate. But for home projects I can certainly live with that. So since this heatsink is getting pretty warm, I want this all the way at the back of the enclosure. And then I thought about placing the power supply in the middle, something like this. And then the control board in the front. And then of course the LCD should go into the front panel. And I will also have to make a little board with the buttons. And there will have to be two binding posts and the on-off switch as well. And to cool the whole thing, I'm planning to put a fan right in the middle of the box and then make venting holes behind the heatsink. So we'll kind of force the air down through the box and cool these components first, and make sure that the hot air from this is not going this way but that way. So I already went and made the drawings for it, and here you can see the top with the hole for the fan in the middle. I will add a metal fan grill on top, because I thought that if I make it in the acrylic it will be too thick and not enough air will be able to pass through. But I might be wrong. And here you can see the front of the enclosure with a hole for the power button and for the screws, and the big holes here are for the push buttons. There's no cutout for the display because you can of course see through the acrylic. And here is the backplate. And you can see the venting holes there. I won't show the other pieces because it's just plain sheets. They do also have these finger joints, of course. And that is how the sides are gonna fit together. So I'm planning to glue these together and then screw the top on. So I will actually modify the files a little bit so I can put a nut in one piece and then a bolt through the other. A little bit like how the first MakerBot printers were assembled. But you will of course see that when we assemble the enclosure. And to make it we will use the laser cutter, of course. And this is a cheap laser cutter that I bought in China. It's a 40-watt tube and it can engrave or cut in plywood or acrylic. Also some other kind of plastic, but it cannot do all types of plastic. Some of them will just melt and foam up and look ugly. So let's take a closer look. I will probably make a full review of it at some time, but we'll just take a sneak peek today. So here are all the controls, and it is not plugged in yet, so we'll do that later. But it has a main power switch, it has some lights inside, they're not that good, and this switch is not actually connected to anything. Then you can adjust the power of the laser. There's a test switch, so this just manually fires the laser. And you can activate or deactivate the laser. So if you deactivate it, then it will not automatically turn on. And you can read the percentage of the power here. It does say kind of something like ampere meter, but it's not really, it's just a percentage. So the important thing is this one here, and that is the cutting head. And this of course moves in X and Y direction. It will cut 30 by 20 centimeters, and to do the cutting there's a lens in the bottom here and a mirror at 45 degrees, another mirror here at 45 degrees, and there's a mirror inside that hole there. There you can see it, and that's at 45 degrees as well. And behind this gray cover is the laser tube. and we will take a look at that in a minute. It does have this spring-loaded clamp here to hold down your workpiece, but it doesn't really work that well. And on the back of the unit here, you can see we have a huge tube going outside, and that is of course to suck out all the fumes. It didn't come with this aluminium tube, that is something I bought separately. The one that came with it was a crappy blue thin plastic tube. And we can remove the blower. And if we open the back here, we will be able to take a look at the good stuff. And what you can see here is the laser tube. And at the end there you can see the mirror that we could see from the other side as well. And if you take a close look at the laser, you can see there's an outer tube and an inner tube. And that is because it needs to be water cooled. So there will actually flow water in through this silicone tube into the glass tube and then out the other end to keep it cool at all time. And I just have a reservoir of 10 liters of distilled water. So I'll just put this back together and we can start the cutting. I think the first one we will do will be the front panel, and that is also the most exciting because we will also have to engrave the symbols for the buttons, and I have written easy projects on it and DC load 8 amps, and when it have done that it will cut it out. So let's do that. And we will just let all the smoke out. Yeah, that's enough. And here we have it. I'm sorry it didn't show up that well on the camera while it was cutting. So I'll try to see if I can get that better on some of the other pieces. And let's not hope the corner breaks off, because it's starting to bend a little bit. It didn't. So now that all the parts are done, we can take a closer look at them. And it goes like this. So this is the front panel, and it is a bit opaque because the protection film is still on the back. I removed it from the front to do the etching here, but yeah, it's still on the back. And again, I'm sorry you couldn't really see it when it was being engraved, but at least we can see it now. So that was the front panel, and this is the bottom. Nothing interesting there. And here we've got one of the sides, and this wide opening you can see here is for a nut, so we can screw a bolt into it from the top panel. And we have the top panel here, and the fan goes there, and you can see there's a hole here that will, if I get this, yep, that's the correct orientation, you can see we can screw a bolt down into there. But I noticed a slight problem, and that is that they don't quite fit together. There's just not enough room. So I'll have to file these tabs a little bit, but that's not a problem. And this is just the other side. And we have got the back with the vent holes so the air can get out. So I think I'll just go ahead and file these tabs so we can see if it will fit together. I'll be back. And so after a good deal of filing, I think we are ready to make a test fit. So we got the bottom here. We have the rear end. One of the sides. It should go like this. The other side. The front. And the top. And now it does seem to fit together pretty good, but there is a few spots where I removed a little bit too much with the file. It would have been better if it would have just fit together right off the... So let's try to put a screw in the top here. So it's not that easy to get it to stay in the middle here, but once you kind of get it stuck in there, it holds pretty good. So now I just have to figure out where to put the things inside, and I'll have to drill a hole for the power cord and for a fuse. And I'll also have to find a way to fasten these, because we can't have them shaking around all over the place. So I think I will make it something like this, so that we have the heatsink at the back, the Arduino in the middle here, and I think I'll make a little hole in the side here for the USB port, so that I can program it when it's all in the box. The transformer and the power supply I just put here, and I'll add a fuse and a power cord over here. And the front will look something like this. I still need to make the board with the buttons here. And of course when the enclosure is done I will remove the film here, so it will be nice and transparent. So I'll just cut the little hole for the Arduino, and then I think we can actually glue it together. And the holes for the fuse and the power cord I'll need to drill as well. Well, I figured who needs a drill when you've got a laser cutter, so I just cut them instead. And it's also a bit more pretty, I think. And that way I could also get the correct shape for the fuse holder here. So now it will not rotate when it's in the hole. I also made 2 small holes here so I can 3D print a little clip to hold the power cord. So I think I got most of it wired up now, so it's ready for a test fire. I didn't fasten any of the boards or the transformer or anything yet, so I can still get it out if there's something that doesn't work. And on the back here I drilled some holes into the heatsink and tapped them and screwed it to the backplate with some bolts. The rest of it I think I can just stick that down with double-sided tape. I might make a little bracket for the transformer because that has a little bit of weight to it. But I'm not really going to throw it around anyway, so I don't think it's necessary. I also got the PCB with the buttons done, so that's all screwed in place. And I have plugged it in already, so let's see if it works. And it does. And let's also test that it can draw current, so I didn't screw up with any of the wires. Oops. And I think I'm going to start it before I connect the load, just in case that there's a short or something. Then we'll be able to read it on the current meter. And the terminals there are a little close, but there's no short, so. And it does seem to work. So I guess all that's left now is just to glue the case together, and we're done. Do you know what sucks? This sucks. So I was just about to wash all the dirt and grease off it, and I dropped it right on the corner. Back to the drawing board. And what sucks even more is that I didn't have any more 4mm acrylic, so I had to use 3mm. So I guess there'll be a little bit of an overlap at the edges here, but I have to live with that. But also I did actually notice I made a mistake on the first one, because the binding posts should be 19mm apart. At least that's the standard. And on this new one they are 19mm, so you can see they are definitely not on the old one. So I must have put in the wrong number. So while I was at it, I also went and made the symbols a little bit larger, so they are a little bit easier to see. Now I'll just have to see if I can do this without breaking the new one. Dope. And here is what we have all been waiting for. It is done. And it did take quite some time to get it all glued together and getting all these wires made and stuff like that. So let's just take a look at it and see what I've been doing. And I'm sorry if I repeat myself, because I've done so much stuff that I can't really remember what I already covered. So So we can pull the top cover off here. And that of course got the fan mounted in it. And we can unplug that. So I went and 3D printed a little red clip, you can see it down there, and that is holding the power cord so that it will not get pulled out of the unit if someone pulls the wire. So the main power switch has been glued in place, and I didn't solder the wires, I just used connectors so I can unplug them again if I need to. And for the LCD here I used these standard connectors, they are individual. And in the other end I just glued a pin header to them. And for the buttons I just made some pads on the PCB where I surface mount soldered some wires, and they also have connectors in the other end. And I added some epoxy on top of the solder joints to make sure that it doesn't break loose. We have the power supply board here, and I just soldered the wires directly. And I made connectors that plug onto the board. Sorry, this is a mess, so you can't really see it, but they plug in here. The only wire that I soldered is the ground wire, because I want to make sure there's a very good connection. All the connections to the MOSFETs are just done with these connectors. And I went and made a cable for the temperature sensor as well. This yellow one here, and it goes to the sensor, and it sits right here. I wanted to get a very good thermal connection to the MOSFET itself, so I went and made a little aluminium bracket that I screwed in place so it's getting pressed down on the top of the MOSFET. And I went and soldered all the compensation capacitors directly onto the MOSFETs as well. So the display and the buttons are screwed into the front panel, but all the rest of the boards I just stuck down with some double-sided foam tape. And this is actually very, very strong, so it will definitely not get loose again. Of course the heatsink is a bit too heavy to stick down with tape, and it also gets hot, so perhaps that could weaken the adhesive. So I went and bolted that in place, as I said earlier. And you might wonder why the hell I chose to run the power cord out the side here instead of, say, in the back. And I actually don't know why either, but my idea was that if I took it out here, it will definitely not interfere with all these wires. And I wanted to sit on top of my multimeter there, and then the wire will just go down the side here and into the power strip on the back. But yeah, I realized I could just have run it on the inside and pulled it out here, and that wouldn't really make much difference, so I probably should have done that. And I also noticed something else I forgot, and perhaps you also noticed. So when I first designed the board, I didn't know if I chose the correct value resistor, so I didn't put them all the way down in case I had to remove them, but it seemed to work and I forgot all about it, so now they're sitting there in for a year. So I think this is about it for today, but we will of course get back to it because the software is not completely done yet. We still have to calibrate it as good as we can, and also make the other modes. Right now it's only doing constant current, and I also wanted to do pulses and ramps. But let's just do one final test before we call it a day. And so yeah, this is what you get when you buy stuff too cheaply. They didn't drill the hole big enough. So I got this 18 volt battery here, and we can try and draw some current from that and test the load. And that's better. Now you can see what's on the multimeter there. So let's just go into the constant current mode and say we want to draw 2 amps. And we can press start. And you can see it's only drawing 1.95 amps, so it's not calibrated that well. And the fan is starting to spin up. You can probably hear that. And we are dissipating about 36 watts in the heatsink then. And the fan is up to full speed now, and it is definitely pushing some air through. But it's actually not warm air, it's actually pretty cold. Something tells me that we're not that efficient at getting the heat away from the MOSFETs. But yeah, it will do. So thanks a lot for watching this video, and if you liked it, please give it the thumbs up and subscribe to my channel if you're not already a subscriber. And actually I just hit 2,000 subscribers today, and I never really thought I would get that many, so thank you very much for your support. And yeah, I know 2,000 is nothing really if you compare it to some other channels, but hey, it's a lot for me, so thank you. And see you soon for the next one.